So we're here to solve this Kakuro by Dan Katz called Squaring the Circle. It has a really interesting geometry with this center square. We actually have a ring of cells, and I'd actually think that these 4 cells are going to be pretty key for the solve, in part because we'll have ways, and we won't sort of do this right away, but one thing I'm seeing just because of this geometry is I can kind of mark in these cells and then these cells, and I can get the sum of everything in green based off these row clues, and I can get the sum of everything in green and blue based off the column clues. And that's true in every subdivision of the grid. You could do the same thing up here where the vertical clues give you everything in yellow. The horizontal clues give you everything in yellow plus red, which means you know the sum of these 2 cells in red. And we'll come back to that as we work through the grid. To get started though, let's just see how far we can get with standard Kakuro steps. So I'm seeing some places where we've got a small clue and a large clue. 21, if we put a smallest possible value into it, would have to be a 4, leaving behind 8 and 9. And 4 is also the largest value that a 5 can take. So in this cell, this has to be a 4, leaving behind a 1, leaving behind 8 and 9. 27 in 4 cells allows for a minimum of 3, leaving behind 9, 8, 7, or 24. So 3 is the minimum that can be in one of these cells, but 3 can't be in the cell, so this always has to be a 4 or 5. Put behind a 1, 2 in the space. I think that's all I can do up top. 8 can be sort of any values 1 through 5, but that doesn't intersect with anything important. I think the 16 is the thing I can most write into the space. Down below, 4 is 1 and 3, and it intersects as 20, which is a big clue. We'll need to have a 3 there to leave behind an 8, 9. 29 in 4 cells is 5, 7, 8, 9. And the 5 is actually the minimum and maximum value in the cell for what values come up here. 5 for the 8 clue, and 5 is the minimum for the 29 clue. 16 again is 7 and 9. That means across these groups, the 9s are used, so this will have to be only a 7 or 8, which put a 4 or 5 in here. On the left side, this 4 is a 1, 3. Trying to see if there's anything else interesting. So 22 always had to be 5 or larger. 5, 8, 9, or 6, 7, 9, or how that goes, always have to be a 9 in there. 15 always have to be 6 or larger. So actually, here's a cell that's sort of 6 and up, and here's a cell that's 5 and up, and it's actually in a pretty small overall sum of 14. So how do we get a value of 14 here? Well, if we took the minimums of these cells, 5 and 6 gives us 11, leaves behind 3. That's 1 and 2 and what remains, and that's absolutely forced actually because of we're hitting the min-max values. So 5 and 6, putting in a 9, 1 and 2 to finish this out, putting in a 3. A 5 here means 8 and 9 are the values that go in, so this is the only place the 9 goes for the 22 clue, puts in a 5, puts in a 7. And we've actually now like put in the value, so you don't have to do all the math, but we're going to be able to now look at these 2 cells together. So 27 is in the clue, 6 more to finish them out, so this will be 1, 2, 4, 5 with 1, 5, 2, 4, 4, 2, or 5, 1, but we know that these cells are going to add up to 6. Since I don't see anything else to do right now, let's actually add up everything in blue as I've now colored them. 9 and 13 is 22, and 21 is 43, and 6 is 49. So blue is 49, 5 and 27 is 32, and 27 is 59. So these cells, let's color them red, are equal to 10 because 59 is 10 larger than 49. So that means if 1, 2, 4, 5 are on the left, 5, 6, 8, 9 are over here, and one set of values I can remove are the 2 repeated 5s. Let's sort of do this thinking again now with yellow and try to get these 2 values in pink. So 8 and 14 and 8 is 30 and 16 is 46, so yellow is 46. Coming down, these are 26 and 32 is 58, so 12 is the sum in pink. So this will be 3 or 4 or 6, and we'll again eliminate the duplicated values. We can't have 2 6s coming through this space. It looks like we're now with the 8, 9 being shaded in here, we have a case where this is only now 1 or 2. This is only 4 or 5. I can actually short circuit doing, I guess, a few ways doing the next step here. First of all, these will always be paired sums, so I can already know that the sum of these is 8, and 4 and 4 or 5 and 3 are the ways to go there. The others I've actually marked a 4, 5, 4, 5 pair here, so this will be 3, 9, 1, 5, puts in a 4 with an 8, 8, 9, 9, 7 to finish out space. The 9 up here puts in a 7, puts in a 9. 9 now means that this 16 is 1, 2, 4. And what does that do over here? Well, 1 can't be with this 8 because it would put in a 7. 4 can't be with a 4, so this is 2, this is 6. Get this in. We still need to have this be a valid total sum. And right now it's adding up to 25 with 7 more to go. That's not 1 or 6 or 3 and 4. This will have to be 2 or 5. One of the things to observe is that a 4 never goes with a 2, 5. An 8 value is 1 plus 2 plus 5, or it's 1 plus 3 plus 4. So if a 2, 5 is here, this will have to be a 1. Makes this a 4, means this is the other of the 2, 5 pair. 5 can't be with itself in a 10 clue, so this is 2 with 8, 5 with 2. Now for the top, the 1 cancels this, makes this as a 2, 4. The 9 cancels this, makes this an 8, 9. We have 8 and 6 to finish this out, and the 8 would put a small value here, which is already in the grid, so 6 with 3, 8, and the remaining digit of 4, and we finish the grid. So really elegant puzzle by Dan. It didn't require at the start, at least we could finish this whole left side before we worked through these cornering cells, but this squaring of the circle, these 4 cells, were key for the whole Kakuro solve. And hopefully you got a sense of how to use these enclosed spaces to get the values for these outside clues by taking the difference of 4 sums and 3 intersecting clues to get those values. So hope you enjoyed this video, and we'll see you again soon.